So yes, now what we've talked about in this unit so far is we've talked about basically simplifying exponents, converting them between exponential and radical form. But we haven't talked about what happens when you have negatives, when you have to combine the fractions together. What happens when you have to deal with moving these things around between the bases around? What is the base specifically? Does the negative apply to everything or does it not? We really haven't gone into depth on the more complex ones. So again, exponential laws are what you need to recall here. The fact that a to the m times a to the n is going to equal am plus n. You guys know this one. You've seen it a million times. Okay? An example of that being is if I have a squared plus a to the third, I get a to the fourth. Notice that the base must be the same. Meaning, yes. Oh, that should be 5. Thank you. Sorry. There we go. Thanks. Should be 5. Okay, meaning that, for example, a squared plus b to the third does not equal ab to the fifth or a to the fifth or b to the fifth. You can't combine them. Okay? The same holds true when you deal with radicals. Okay? If radicals don't have the same index, you can't combine them. But if they are, you can combine them and multiply what's inside. Right? You start to see some parallels here. The other one is power to a power. A to m to the n, which is the same thing as a to the m times n. An example of that being, if I have a to the third to the second, I get a to the sixth. Notice the parentheses. Okay, you need to make sure you pay attention to the parentheses. They will tell you who's going to go where, okay? And finally, the new one, honestly, that you probably haven't seen before and what you need to remember and talk about today. We'll do a few examples. We're not going to do a bunch. We'll probably do 3, okay? If I have, let's say, I don't know why the camera keeps tacking out like that. I think it's starting to die, so I apologize if it's flashing. All right. A to the m divided by a to the n, I get am minus n. An example, let's say I have a to the 12th over a to the 9th. That's going to give me a12 minus 9, which equals a to the third. All right? The bases again, what happens with the same thing with addition when you're multiplying radicals together, right here, right? And that should be actually a plus sign on that previous one. I just noticed that too. Not a plus sign, should be a multiplication sign. There we go. Okay? When you're multiplying exponents together, you add them. When you divide them, you subtract them. Okay? And again, the same thing applies to what was set up here. Notice that the base must be the same. Okay? Any questions on that? Okay, good. All right, so let's go ahead and do some examples real quick. All right? I'm going to do 3 examples. Let's say I have, for the first example, on number 1, I have x to the 1/4 times x to the 3/4, okay, equals x to the 1/4 plus 3/4. Okay, right, because we're adding the exponents across, so we're going to add them. That gives me then x to the 4/4, which gives me just x. So nothing really there exciting. Now, alternatively, if this had been, let's say, 5/6, and then I said I wanted to convert it to exponential form, you would obviously make it, 5/4. You'd obviously make it to the 4th root to the 5th power, right? Mm-hmm. So, number 2, okay, we've got x to the negative 1/4 to the negative 2/5. All right. If I simplify that, I have x to the negative 1/4 times negative 2/5. I should have wrote that as a traditional style fraction, not sideways. Okay. There we go. All right. I multiply those together and I get x to the 1/20. I'm sorry, 220, which reduces to x to 1/10. And if I wanted to write that in radicalist form, it would be the 10th root of x. Right? I apologize again for the flash. I don't know why it keeps going in and out. I think the camera's just dying. X to the 2/20ths. For this one, you mean? Yeah, that's supposed to be it too. Okay. I'm going to pause that here for a moment. Now I'm going to go and go on the next page real quick for these last 2 examples I want to do. Oops, sorry, I bumped the camera again. Hold on a minute. There we go. All right, last 2 examples we're going to do. So technically there's actually one more I want to talk about. All right, so number 3. Number 3 was, let's do a to the 3/4 over a to the 1/4. Rewrite that as subtraction, so it'll be a to the 3/4 minus 1/4. That's going to give me then a to the 2/4, which gives me a to the 1/2. And if I wanted it in radical form, I would write the square root of a. Because obviously the base here is 2, or the index, which will become right here, is 2. And that goes right there. Okay? All right, any questions? Yep. All right. Last problem. We're going to do, which is number 4. Oh, wait, hang on. I can keep that up there for those of you who are still copying. Sorry. And again, I do apologize for the flashing. I don't know why it keeps wanting to go out and coming back the picture. Number 4, we're going to talk about one more specific problem. B to the negative 4/7. Okay. Actually, let me rewrite that. I like how I wrote it in the previous one where I put the exponent on one line and the variable on the other line. Kind of works a bit better. So B to the negative 4/7. Now, when you have an exponent in that is negative, what you need to do is you need to put it in the denominator. Remember, every single number is technically over 1. So what we're going to do, move negative exponents to denominator first. Meaning that if you have one where, for example, if you have negative b to the negative 4/7 over b to the negative 1/2, all you need to do is flip them. Just flip the entire thing on its head and basically move 1/2 up here and 4/7 down here, okay? So you basically can flip them around, but we're just going to look at one on its own. But that's the general rule. Move them first before you do anything. You don't want to deal with negatives if you don't have to in exponents. They're not fun, as you clearly just saw in the previous example. Or no, sorry, not in the previous example. But even if that was the case, when you're doing subtraction, that's a risk. So if we move them, what we're going to end up getting is essentially 1 over b to the negative 4/7. We then, positive 4/7. What am I doing? We then multiply. We then do the, then we do, actually, why would you do the conjugate here? Okay. Now, if you want to simplify this, what you can do is you can then multiply it by b to the 3/7 over b to the 3/7, which is effectively multiplying it 1/1. We do this so that way we can get rid of the fractional exponent on the bottom. Realistically, you don't have to worry about this part. I'm not going to give you a problem like this in honors, but I'm showing this to you now, this extra step. So what I will do is this. I want you to label this as extra. Okay, I know, we're almost done. Okay. Is it supposed to be 4/7? Okay. I'm reading off of. It should be 4/7, and that's exactly what we want, because when we add it across, then it'll basically make b over the other one.
Why did you do it wrong the first time?
Because the guide I'm looking from was from another teacher, and clearly they had a typo. So thank you, Lily, for catching it. Okay. So we go ahead and multiply that straight across, which is going to leave us with b to the 4/7 over b. That simplifies. Let's see, add it would be basically, so add them, so it's going to be what? 8 over 14. Okay. And then you could technically stop there. If you wanted to find the subtraction, you could, but then you're back where you started. So that's basically the expanded form of it. Again, this is extra. You don't need to do this. I am perfectly fine if you stop here. Okay? But basically, I just don't want negative exponents. If you want to put it 1 over, that's fine. All right? So I am going to double check something. Why this is the last thing we're talking about in this, because it can be a little jarring when you first see it, and why I didn't give it to you guys yesterday. Okay, so again, this is just all extra. You don't have to do this unless you want to basically make it to where you have b's both on the top and they're easy to simplify. It's just fraction manipulation. Yes, Joey. Yes. All right. So hopefully that answered all your questions. You have homework tonight. Good luck.